NASA. We're asking commercial companies to provide proposals for collecting of space resources in support of the Artemis program. The requirements: a company has to collect a small amount of moon dirt from the lunar surface, provide imagery and data to NASA, and conduct an in-place transfer of ownership of the material to NASA. We also asked our commercial lunar payload services partners for bids to fly a suite of science and technology payloads to the moon in 2022 that will help lay the foundation for human missions to the lunar surface. Next-generation lunar science and technology is a main objective for returning to the moon and preparing for Mars. A NASA project is developing special gears able to withstand extremely cold temperatures on missions to the moon and other destinations in our solar system. The gears are housed inside a metallic glass material able to survive the extreme cold without needing the usual heating. As California experiences one of the worst wildfire seasons on record, NASA's Earth-observing instruments on spacecraft, satellites, and aircraft are providing data to agencies responding to the emergency, including public health officials monitoring diminished air quality and visibility. The fires have burned more than 300,000 acres since August 16th. This animation from our OSIRIS-REx mission shows the trajectories of particles emitted from the surface of asteroid Bennu during several months in 2019. Ongoing examination of Bennu and a sample of the asteroid expected to be returned to Earth could help the OREX team learn exactly why this phenomenon is occurring. The spacecraft is set to touch Bennu and collect that sample on October 20th. Just in time for the new school year, the Celebrating Station Science online resource is available to connect students and educators to 20 years of space station experiments and research. Each month we'll have lesson plans, activities, information on space station science, and other resources for the Artemis generation of explorers. Check it out at nasa.gov/STEM/ISS20. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/TWAN.
Above South America, a weak spot in Earth's magnetic field is evolving. Called the South Atlantic Anomaly, this unique region has been expanding for more than a decade, and scientists believe that it's beginning to split into two distinct zones. Now, while this anomaly poses little risk to life here on Earth, it does allow scientists to study the complicated mechanisms behind Earth's magnetism. Around 1,800 miles below the surface, dynamic processes in Earth's liquid iron outer core are continuously generating electrical currents. This accounts for the majority of Earth's magnetic field. But unlike a typical bar magnet with one north and south pole, Earth's magnetism isn't all neat and tidy. If we take a look below the anomaly at the boundaries separating the core and the mantle, we can see the magnetic variations are much stronger. This picture provides a clear link between the anomaly we see in Earth's magnetosphere, its origins deep within Earth's interior, and how it's projected to evolve in the near future. This is important to understand because our planet's magnetic field plays a huge role in shaping the near-Earth environment. In addition to guiding compasses and animal migrations, the magnetic field acts like a shield, repelling charged particles flung from the sun that could be disruptive if they reach the surface. Many of the particles that do slip inside Earth's protective bubble become trapped in large rings of energetic particles called the Van Allen belts, which are held in place by Earth's magnetic field. The inner edge of the innermost belt is about 400 miles from the surface of the Earth at the equator, which keeps particle radiation a safe distance from Earth and orbiting satellites. But because of the offset between Earth's magnetic and rotational poles, and the weakened magnetic field over the South Atlantic anomaly, some energetic particles within the belts do penetrate closer to the Earth's surface. This means that NASA and other space agencies need to account for the extra radiation when low-orbit satellites pass through the anomaly. Currently, NASA researchers are using data from satellites along with theoretical models to track the evolution of the South Atlantic anomaly and help prepare for future challenges to managing satellites and humans in space.